All right, in this video I'm going to be working through the problems in BC Review number 8, which was multiple choice with calculator. Okay? So we're going to start off with pink X. I'm going to just make sure to really clearly label which problem I'm working on and just work in that same color the whole time. So I am starting with pink X. All right, pink X is the graph of a function f, which consists of 3 line segments, is shown in the graph. The function f is defined on the closed interval 0 to 6. Let g of x equal the integral from 2 to x of f of t. And we want the maximum value of g for x being between 0 and 6. Find the maximum of g for x in the closed interval 0 to 6. So what we're going to do is we're going to have to run the candidates test. So I need to consider the endpoints, see what happens at x equals 0 and x equals 6. And I also need to consider the critical points. Where is the derivative of the thing I'm trying to maximize equal to 0? Well, g prime of x is equal to f of x. G prime equals 0 at, it looks like, x equals 3. So I'm just going to try x equals 0, x equals 3, and x equals 6. And g, we just have to count the integral from 2 to x. So the integral from 2 back to 0 is going to be -4 because it's that area of that rectangle as you move backwards. Area is 4, but you're moving backwards, so it's going to be -4. Okay. G of 3 is going to be, I'm going to add, which has a base of 1 and a height of 2, so that's going to be 1. And G of 6 is going to be 1 minus something. Because of the amount of area that's underneath the x-axis, meaning that 1 is going to be the maximum value. Okay. Next, I'm going to be working blue Z. It's because they were requested in class, you know. All right. Blue Z, that's farther down on mine. All right, the velocity vector of a particle moving in the xy plane has components given by, that was polite of them. Oftentimes they'll just give you the velocity vector and expect you to know that the x component is dx dt and the y component is dy dt. Just making sure, okay, sine of t squared. And dy dt is, what is it? E to the cosine t. Right? And, oh, and they want to know the ending y coordinate. So y of 3 equals, well, what I'm trying to find. And y of 4 equals 1. So what they say is at t equals 4, the position is, what, 5, 2, 1. We don't care about the x coordinate because they're just asking us about y of 3. Well, I know how to find y of 3. That's going to be y of 4 plus the integral from 4 to 3 of y prime of t dt. And then I'm going to pull out a calculator. What are we doing? I'm making glare.
Didn't work.
Didn't work? Are you in radian mode?
No. Oh, wait, yes, yeah.
Oh, okay. Well, I thought that's always an easy fix. I don't know. Let's look. So 1, because y of 4 is 1, plus the integral from 4 to 3 of e to the cosine t dt, and 590, that's answer choice B.
Oh, I plugged in 3 for x because I thought it was
Yeah. We're going to let x range. All right. Any others from my in-person people? Any requests? Yes?
The error bound one?
Oh, yeah. That's going to be the last one. That's going to be black Z. That's a good call. Okay. I did hear the dinging of someone saying something in the chat, but I can't like get back into the Google Meet right now. If you could email that request to me, it will go to my phone and I will see it. I think that's what we're working with right now. If I don't see anything after I work black Z, I will pause the recording and jump back into the Google Meet and see which one it is that you had requested. But who knows? Maybe this person had requested black Z. All right, black Z is the alternating series error bound. And we do have a calculator with this, so that should help a little bit. All right, so the infinite series S equals the sum from 1 to infinity of -1 to the n plus 1 times 2 over n. Okay, we're going to approximate it with a partial sum, and it's like, what is the lowest number of terms that we can use to actually, I just started one. To guarantee that the error of that partial sum is less than 3 over 100. So we want error less than 3 over 100. So we know that error is just the next term. So we need to figure out how many so that the next term goes under 3 over 100. And just looking at the answer choices, I've got 64, 66, 68, and 70. So I'm just going to start working with those. And so the absolute value of the next term is just going to be 2 over n plus 1 maybe. But what I'm going to do is I'm just going to say, I'm going to bring out the calculator and start looking at what happens when I do 2 over n. So 2 over 64 is too big. 2 over 66 is still too big. 2 over 67. Okay, that's the first time it went under. And you might be tempted to say, okay, so the answer is 67. But that means that 67 needs to be the error term, right? The thing that we're using. So I'm going to choose B, answer choice 60, which is 66 term. All right, for red Z, I'm going to copy most of the problem. F double prime is x minus 1 squared, x plus 2 to the third. Plus 2 to the third, just making sure that's right. G double prime is F double prime plus 1. And H double prime is F double prime minus 1. Just to save myself some writing. So what I'm going to do is I'm going to draw you a picture of F double prime of x, right? I've got zeros at -2, 0, and 1. And this is a 6th degree polynomial with a leading coefficient. So I'm going to I know it's going to be like that. Okay, it's going to pass through 0 with confidence. It's going to slide through here hesitantly. And it's going to bounce at x equals 1 because of the 2, the 3, and the 1 power of x there. So at -2, we are going to hesitate. And then at 0, we're going to pass through with confidence. And that makes sense, that it would need to bounce here in order to respect the end behavior that I know it needs to have as a 6th degree polynomial with a positive leading coefficient. All right, so how many points of inflection am I seeing there? I'm seeing 2 points of inflection. And, okay, well, I know that I can eliminate A and B, those answer choices, because, well, I mean, yeah, it doesn't really seem likely. Okay, now, I don't think the whole reason I can't do this without a calculator is I don't know how deep that distance is, right? If that distance is more than 1, I can guarantee that F double prime plus 1 will also have 2 points of inflection because, say I shifted it down by 1, I'm going to use a color other than red, but I think you'll forgive me. Then this would become the x-axis, and we would have 2 sign changes on double prime. I mean, I have 2 points of inflection, but I don't know that, so I need to go in, and I need to just graph the thing. So I clearly was doing some other stuff there yesterday. So x times x minus 1, no, that's to the 2, plus 2 to the 3. And okay, before I go on, I know that -1 is not going to be probably the case, because I think it's going to catch more intercepts here. There could be like up to 4. Yeah, there could be up to 4 intercepts when I subtract one, or when I, when I subtract 1. So I'm going to add 1 and graph it on the window. Hold on, it's not even over here anymore. -3 to 2. That should be good, right? Okay, 1, 2. I'm happy. All right. So the +1 is definitely an answer. So I'm down to, well, I was, okay, that wasn't smart. Just to talk about on a multiple choice level, since I had already eliminated A and B because I knew F worked, I did not need to check G because that was both of my answers that I had left had G in them. Pardon me, I was just wasted your time for a second there. And then, okay, there's 1, 2, 3, 4. Okay, that's an issue. So it's going to be answer choice C. All right, that was red Z. Now for pink Z. I think the difference between red and pink picks up pretty well on the document camera. All right, this is a polar area. It kind of looks like a, I don't know, kind of a lemon or something. R equals cosine theta and R equals 2 theta. Oh, the tricky thing here, is this the one where they give you the intersection? Yeah. This is theta equals 0.45. All right. So the thing here is that that's the origin. So what we're going to be doing is we're going to be integrating on 2 theta from theta equals 0 up to theta equals 0.45. And then it's going to switch, and we're going to integrate on cosine theta from 0.45 to what looks like, going to be pi over 2. And kind of the trick that I have told y'all in the past is if you start at the pole, at the origin, and you draw a straight line to the edge of your region, and you hit both curves, that's when you have to subtract. But if you're only hitting one curve, that's where we're going to have to split it up into 2 and add. Okay, so this is going to be equal to this area. We know it's 1/2 r squared d theta. So it's 1/2 the integral from 0 to 0.45 of r squared d theta plus 1/2 0.45 to pi over 2 r squared d theta. And that's a job for the calculator. You type it in. What did y'all get on that? Do we know what answer choice it is? B? Like boy? Yeah. Cool. Yeah. Answer choice B, 0.243. Cool. All right. Any others? Otherwise, I think, have I done all the Z's? No, I haven't done green Z. Green Z. Love green Z. But evidently I got some people tricked by it. Yes. Green Z. All right. So F is increasing from 1 to 3. Only. So I've got this 0, 1, 2, 3, 4 table. And so I need to see from 0 to 1, I'm going to need to see decrease or stay the same. Then from 1 to 2, I'm going to need to see increase, but then I'm going to need to see either the same or decrease. Only one that fits that is answer choice C, right? What? Wait. Oh, no. I thought we were looking at a graph at a table of values for F this whole time. I was like, why would they give you a table of values and say that it was increasing? Okay, that makes way more sense. All right, so we're just looking for positive, 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 not positive, not positive. I think that is the case.
No, there's one.
Because, this one is tricky. It's because of the fine print. These do have to be 0 because, so they give you the little tidbit, f prime is continuous. So let's draw a picture of this, right? Here's 0, 1, 2. Oh, this is tricky. I thought this one was really easy, and it was not. And, okay, hold on. So, if f prime is positive on 1 to 3 only, and it's continuous, it has to be negative elsewhere. So it has to go from negative to positive there, and positive to negative there. And we don't really know what's happening besides it's continuous. That was tricky. So I'm looking for, ones that is 0, positive 0. Oh man, that was very subtle. I like that question. That one's getting used next year, I guarantee it. I think this is a problem set that I have not ever used, except I know that polar area question and the alternating series error bound one, but maybe I just trawled through it and pulled a couple of them, but not that many. All right, that's all the z's. I had done some x's, so I'm going to go back to the x's, and then I'll wrap up with the y's. All right, red x. This is my first one. I don't know about y'all. Oh, wait, no, it was random. All right, which of the following guarantees that there's a relative minimum at x equals c? Oh, okay, relative minimum. That's where it's concave up and flat. So I'm looking for f prime of c equals 0 and f double prime of c is positive. Love that one. That's answer choice C. I'm going to be confident in that answer, and I'm going to move on. Okay, blue x. Did I already do blue x? No. I did blue z. I've got the list of problems I've done in front of me, so I won't do the same problem twice. So I would do that. All right, blue x. Let's see. H is an antiderivative. For the function x to the 3 plus sine x over x squared plus 2. Meaning, if h is the antiderivative, this is the derivative. So, if h of 5 equals pi, then h of 2 equals h of 5 plus the integral from 5 back to 2 of h prime of x dx. Okay, h prime is this function right here, so I'm just going to, plug in to my calculator. So pi plus the integral from 5 to 2 of, use the fraction bar. Oh wait, even using the fraction bar, I almost made an error. X to the 3 plus sine x, I'm in radian mode, divided by x squared plus 2. I don't know if that's going to be an issue. I will close the parentheses. Dx. And then I'll sit and wait for a second. Negative 5.867. Cool, that's choice B. Great. All right. And yeah, that was blue x. I need to zoom out a little bit. That's not great, but green x. Okay, they're saying the continuous function f is positive and has domain x greater than 0. The asymptotes of the graph of f are x equals 0 and y equals 2. Which of the following statements must be true? All right. Well, okay, I need at least one of the limits at infinity going to y equals 2, right? I don't know. I could have something that, came from above and then just approached 2 as I went over there. I'm not talking about the vertical asymptote yet. Like e to the x, or e to the negative x plus 2 is something that could, approach this asymptote on one side, but not the other. So let me just look at the answer choices. Okay, I know B is wrong, because the limit as x approaches 0 of f of x is not going to exist, because there's a vertical asymptote, right? Like, I don't know if it actually looks like that, or maybe it came from below, or maybe they're together up here, or maybe they're opposite. I don't really know. But which of the following statements must be true? Oh, whoa, okay. Whoops. I forgot that it's positive and has domain x greater than 0. So no, I do know that it looks like this, and I do know that it at some point goes like that. It could potentially dip under the horizontal asymptote and then recover and come back. But I do know that the limit as x approaches 0 from the positive side is infinity, and the limit of f as x approaches infinity is got to be 2. So that's answer choice. There it is, C, right? Yeah, there it is. Okay, so that's C. Okay, I already did pink X. Let's do black X. All right, black X. The position of an object moving along a path in the xy plane is given by the parametric equations x equals 5 sine of pi t, and y is 2t minus 1 squared. Okay. The speed of the particle at time t equals 0 is going to be, okay, so the square root of x prime of 0 plus y prime of 0, each of them squared, added together. Okay. So what I'm going to do, I think that I can faster do this, do the derivative step by hand than typing through Math 8. Who knows? Maybe I'm wrong. But I know this is going to be x prime is 5 pi cosine pi t, and y prime is 2 times 2t minus 1 to the first times 2 is going to be 4 times 2t minus 1 to the first. 4 for the chain rule, 2 for the power rule, the other 2 for the chain. All right. And so at 0, I've got y prime is negative 4 and x prime is 5 pi. So y prime is negative 1 times 4 is negative 4. All right. So, yeah, no, right underneath the fluorescent lights. All right. Okay, it's really important that you put that in parentheses, because if you just square 5 pi without them, it's only going to square the pi, right? Because it respects PEMDAS, it wants to do exponents before multiplication by 5. And then I'm going to add 16 to it, and then I'll get 16.209, and that's answer choice D. All right. Oh, looks like I've run out of lined paper. That'll be all right. Just write smaller. All right, red Y. Which of these graphs could be the antiderivative? Okay, this one's going to be tough for me to write anything down on, but... So, if here's F, and it goes like that. Well, that means we're looking for an antiderivative. So say we're looking for g where this is g prime. If this is the derivative, then the function needs to be increasing from negative 1.5 to 1.5, approximately. And I think that it needs to be increasing, right? So the only one I see that, oh no, I see two that are making that happen. That's C and D. So what do I need to do? What do I need to be thinking about there? It's respecting the increasing, decreasing. So I have to figure out what's the concave up, concave down behavior. So what I'll say is from -2 to -1.
Wait, so there's two that increase?
Yeah, C and D both. Oh, no. Yeah, no. C did not uniformly increase, so it is D. Answer choice C was mostly increasing, but it did a little bit of it was. Hold on, it was mostly increasing, but then it did a little dip. And well, we know that it needs to be constantly increasing because this is constantly positive, and it's the graph of the derivative. I think that's enough to say about that. All right, blue Y. This is another absolute maximum question, but I guess this one you actually have to use the calculator for. We'll zoom in once more. Yeah, that'll be. All right, so for blue Y, f prime is e to the -x cosine x squared. Oh, I see what they're getting at here. F prime of x is e to the -x cosine x squared. Okay. We want the minimum value. Oh, no. Oh, okay, yeah. They're really asking you what is the x coordinate of the minimum value. I was like, I knew that because it's going to be only increasing then only decreasing or something like that. So minimum on -1 to 1.
This one take me out.
All right, so I'm going to graph the derivative, and I'm going to just hopefully see what they want me to see. You know, e to the -x cosine x. E to the -x cosine x. I'm in radian mode. Always worth checking anytime you type in trig on your calculator, especially if you're like a physics student or something. And no, I want to graph this on -1 to 1. And hopefully, all right, it's always positive. Wait, is it? So, all right. The question is like, hey, did this actually hit 0 or what's going on here? I'm going to calculate the value at x equals +1, and I see that it's still positive. Okay, so it looks to me like e to the -x cosine x is always positive, meaning this is the graph of the derivative. If the graph of the derivative is always positive, the function's always increasing, which means the minimum value was, well, right where it started. And that would be f of -1, which is answer choice A. Is that the right answer? I think.
Yes.
Yeah, okay, cool. Just making sure. I don't know why I was doubting myself on that one of all of them, but I was. So here we are. Okay, yeah, I liked this one a lot. Green Y. So this is just a nice area volume situation. I'm just going to talk about that as F because it doesn't really matter what it is. It said cross sections perpendicular to the x-axis are a rectangle. Well, that's going to be the base of my rectangle. My height is always 3. Remember, we want to get volume by integrating the area formula, but the area of this is 3 times the base. So it's going to be the integral of 3, and the base, that's f of x. It really is top. Let's say you wanted to do top minus bottom. It's y equals f of x minus y equals 0. From 0 to 2 or something, yeah. So that's answer choice A. Okay, that one was really friendly. We should all be so lucky as to get asked about a volume that has cross sections that are rectangles with height 3, because that makes the thing a prism, and we know that it's actually quite easy to find the volume of a prism. Or maybe you took that from your geometry class. I hope. All right, I'm curious. How do we do on pink Y? Because I hope we did well on it. It's a really, kind way for them to ask you about an improper integral. So I'm going to start off with the integral. Integral from 1 to infinity of g prime of x dx. This is not free response, so I'm not going to go through the whole rigmarole of transforming it into a limit. I'm just going to say, all right, first step, antiderivative. That's g of x. As we go from 1 towards infinity, right? That's like the limit as x goes to infinity. So I'm going to just say, well, the limit of g as x goes to infinity was 4. And then g of 1 was 0.5, and so that's 3.5. All right, class ended. I'm not sure where I was at, but that was, answer choice B for the pink Y problem, the improper integral. That was pretty friendly, right? It's kind of, do you know your fundamental theorem of calculus? All right, so the last one I've got is black Y, and Well, that's going to be tough for me to work without having the picture here, but I'm going to do it anyway. All right, so for the black y, we want g of 10 times g prime of 10. Oh, actually, this one is not going to be as bad. Okay, because they're saying they're defining g of x equals the integral from 2 to x of f of t dt. Okay, and they want to know what's like g of 10 times g prime of 10, right? Okay, g of 10, we're going to have to do some area counting, but it'll be all right. And I think some of these areas are going to balance. 2 to x, that's a little annoying. But we can engage in some square counting, we'll get the answer. Okay, g prime of x is equal to f of x, meaning that g prime of 10 is equal to f of 10, which is negative 1. Okay, so that's nice. Now, I need to find g of 10, which is going to be the integral from 2 to 10 of f dt or dx, or whatever. Just area under the graph of f from x equals 2 to x equals 10. Now, I've got, let's see, I'm going to need to zoom back a little bit. That'll work. I'm going to draw you a little picture down here. At x equals 2, it's flat up at y equals 3. And that lasts for 1x. Then there is a triangle with width 3 and height 3. Then from 6 to 8, there's a triangle with, hold on, this is 9 over 2. Let's just say 4.5. This is 3. So I'm at net 7.5. Here, I'll circle my area numbers as opposed to my dimension numbers. Then 6 to 8 is 2. Yeah, so that's negative 2. And then from 8 to 10 is going to be negative 3. Just kind of on a square counting level. So this is going to be 7.5 minus 5 should be 2.5. So that's going to be answer choice C. Okay. So the integral is equal to 2.5. Negative 1 times 2.5 is negative 2.5, which is negative 5/2. That's answer choice C. All right, and that's all I got for you for this one. I will have another multiple choice with calculator section available for you. Be on the lookout for that. That one can replace a minor grade or whatever. But, you know, if you found this video helpful, I might ask that you consider liking it. But that's all I got for you.